You are handed a priceless piece of history, but you have a problem. You need to verify if this ancient crown is pure, solid gold or a clever forgery made of a cheap alloy. You cannot take a drill to it. You certainly cannot melt it down. Traditional chemical tests involving corrosive acids would permanently damage the very artifact you are trying to verify. Authentication requires moving beyond visual inspection to examine physical properties that remain unchanged by the object's shape or age. The goal is to look directly through the solid metal to see its internal composition, relying entirely on the laws of physics. Specific gravity measures relative density. Pure gold is exceptionally dense, at exactly 19.3. This creates a physical limitation for counterfeiters. To build a fake from a cheaper metal like silver and have it weigh exactly the same, they must use more material. That extra material means the fake object is physically larger. It takes up more volume than a pure gold piece of the exact same mass. Unmasking a counterfeit relies on quantifying this hidden discrepancy in volume. To find that volume, we use Archimedes' hydrostatic weighing method. Step 1 is straightforward. Place the object on a dry scale to measure its standard mass in the air. We record this number as W1. Step 2 requires water. You place a filled cup on the scale and then reset the digital readout back to 0. Next, you suspend the gold from a fine thread and lower it until it is fully submerged. This step demands total isolation. The artifact must hang freely, avoiding any contact with the glass walls or the bottom. As the metal sinks, the scale begins to register a weight. The displaced water exerts an upward buoyant force against the object, and that fluid reaction pushes back down against the bottom of the cup. We record this new number as W2. W2 is not the weight of the gold. It is the precise weight of the water pushed out of the way. Because water has a known, steady density, that weight provides a perfect numerical stand-in for the artifact's exact volume. This equation is our final calculation, dividing air weight, W1, by displaced water weight, W2. Expanding those variables reveals the physics. The top is object density times volume and gravity. The bottom is water density times volume and gravity. Since we use the same object, volume and gravity are identical and cancel out completely. Standard water's baseline density is exactly 1, so the denominator vanishes. We are left with the exact specific gravity. A final result near 19.3 confirms the piece is pure gold. If the score drops into the 15 to 18 range, you are dealing with a fake. That lower number proves the object had an inflated volume and displaced far too much water for its weight. Through basic arithmetic and gravity, the internal composition of the metal is laid bare, without leaving a single scratch on its surface. However, this method relies entirely on absolute physical precision. The slightest environmental flaw corrupts the math. If even a microscopic air bubble clings to the submerged gold, it acts like a tiny balloon. That bubble artificially increases the buoyancy, inflating the W2 reading and ruining the final ratio. The physical setup is equally sensitive. If the gold bumps against the glass, it transfers its actual weight directly into the scale, entirely bypassing the buoyant force. The math works perfectly, but the test is only as reliable as the flawless execution of the environment around it. There is one material that can effortlessly defeat Archimedes' math: tungsten. Tungsten shares a nearly identical density with gold. A fake artifact built around a tungsten core will displace the exact same amount of water as a solid gold piece, generating a deceptive score of 19.3. Because of this density match, high-stakes modern markets must rely on ultrasound technology to look deep inside bullion and catch these perfectly crafted fakes. While it cannot beat a perfectly matched material like tungsten, the hydrostatic test remains an elegant piece of problem-solving. It proves that with a scale, water, and sharp logic, we can expose the invisible properties of the physical world.